Okay, we're going to pick up where we left off. The amount of substance initially present was 400 grams, and after 90 hours, only 380 grams remained. Assume an exponential decrease and determine the half-life of the substance. Make a sketch of the graph. Okay, so first of all, remember that the exponential growth and decay function is a sub t equals a sub 0 e to the kt, where a sub 0 is your initial amount. So the initial amount present was 400 grams, so that's our a sub 0. And then it says after 90 hours, only 380 grams are left. So a sub 90 is 380 grams. All right, so the first thing we want to do here is find out what K is. So we're going to go ahead and plug that information in. So a sub 90 is 380 grams, and a sub 0 is 400 grams. And so this is what we have, K times 90 hours. That's how long it takes to have 380 grams left. Divide both sides by 400. And so we've got 380 over 400. We can cancel one of those zeros. So now we take the natural log on both sides. So we'll have natural log of 38 over 40 equals natural log equals natural log of e to the k times 90. And then we would have natural log of 38 over 40 equals k times 90, or 90k. Natural log of e, and natural log of e is just 1. So now we can divide both sides by 90, and we'll get k. So k turns out to be about, we're going to plug that into the calculator. So we'll hit 38 divided by 40, and then hit equals, hit natural log, and then divide by 90. So you are going to get for k about negative 0.00057. All right, so now that we know k, we can figure out the half-life. Remember that the half-life of a substance is the amount of time it takes for the substance to reduce by half. So we're trying to find out what T is when we have 200 grams left, so half of what we started with. So we will say our a sub t is going to be 200, and our a sub 0 is still 400, e to the negative 0.00057 t. And we're trying to find out what t is, the time it takes to have half of this left. So we're going to divide both sides by 400. So that's going to give us 1/2 equals e to the negative 0.00057 t. Take the natural log on both sides to get t. Use the law of logs to bring, I'm going to put a box around this so it doesn't, we don't get confused. Put the exponent that's in the log argument in front. So we'll have natural log of 1/2 is equal to negative 0.00057 t times the natural log of e, which is just 1. And so then we can divide both sides by negative 0.00057, and that will give us t. That cancels. And now we can punch that into the calculator, and we will hit 0.5, hit natural log, then divide by 0.00057, make it negative, and that will give you about, for t, that will give you about 1,216 hours. All right, so if we want to graph that, we can look at the information they've given us. We know that at a sub 0, we had 400 grams, so we can put that there. And then at 90, we had 380 grams, so that would be about right there. And then at 1,216 hours, we have 200 grams, so that's about right there. And then we would just sketch the curve. So remember, when you're talking about decay, when you're talking about a decrease, an exponential decrease, your k is going to be negative, and that's how it'll come up. Okay, this is another one with decay. A radioactive substance decays exponentially. After 100 years, there are 500 grams left, and after 200 years, only 300 grams remains. 300 grams remain, I think, or remains. I don't know. Find the amount of the substance that was initially present and its half-life. So we have to find our A sub 0, and we have to find the half-life. That would be when there would be only half of A sub 0 left. We don't know A sub 0 yet. All right, so first of all, we can use the information they gave us. They gave us A sub 100, so that's the 500 grams. That's A sub 100 years. And then after 200 years, there's 300 grams left, so that would be A sub 200. All right, so in this one, we have to do two equations. So we have A sub 100, so that's 500 grams, is equal to A sub 0 e to the k times 100 years. And then we have 300 grams, and that's going to be A sub 0 e to the k times 200. Or let me just rewrite these, 100k and 200k. 100k and 200k. Okay, so in this situation, what we're going to do is we're going to divide the two equations. So we'll have 500 over 300 is equal to A sub 0 e to the 100k over A sub 0 e to the 200k. So the A sub 0's cancel, and with 5/3 is equal to e to the, when you divide like bases, you can subtract the exponents. So it'll be e to the 100k minus 200k. So we have 5/3 is equal to e to the negative 100k. And now we can solve for k. So take the natural log on both sides. And then we would have, on this side, we can rewrite it as negative 100k, natural log of e. The natural log of e is 1, so that's multiplied by 1. And then we can take the natural log of 5/3. So I would hit 5 divided by 3 equals, then hit natural log, then divide by negative 100. And you have that k is about negative 0.00511. Now, we can plug k back in to figure out what A sub 0 is, but we don't actually have to do that because we know that the half-life of a substance is when you have half of it left. So 1/2 A sub 0 is what we want to have left. And then that would be A sub 0 e to the kt. And we know that k is negative 0.00511. And we're looking to find out what t is. So this would be a way you could do it. You could plug k in, find out what A sub 0 is, and then go back and take half of A sub 0 and put it on the left side like we did in the problem before. However, it's probably even quicker to do it this way, because this way you can just cancel the A sub 0, and then you're going to have 1/2 is equal to e to the negative 0.00511t, and you can take the natural log on both sides, and then you will put that exponent out in front, and that cancels because it equals 1. And then you can hit 0.5 natural log divided by 511 negative, and you will get that t for the half-life is about 136 years. And then to graph that, we can just put in some of the points we started with. So after 100 years, there were 500 grams left. And after 200 years, there were 300 grams left. So at this point, we find out that, yeah, we probably kind of do need to know what a sub 0 was because we can't put it on the graph. So we'll go back and find out what a sub 0 was. So we'll just use this equation right here. So that is 500 equals a sub 0 e to the 100 times k, which k is negative 0.00511. And then if we divide both sides, well, let's go ahead and punch in e to the 100 times negative 0.00511 and see what that is. All right, so I would say I would multiply 100 times 0.00511 negative equals, and then I'd hit inverse natural log to put that on the e. And then that's what I want to divide both sides of this equation by. So I am going to say, I'm going to hit 1 over x, and that'll make it that I'm multiplying that by 500. And so I get that a sub 0 is about 833. So now I know what my a sub 0 is, and I can put that on the graph. And so that would be about right there. And then I can sketch the graph. Oh, and that's the half-life. So that was 136 years until we had half of it left. And then I can sketch the graph.